Bismillahir Rahmanir Rahim. Assalamu alaikum students. This is Hamza Noor, and in this particular video I'm going to solve the question number 3 of International A-Level Edexcel P4 January 2022 paper. So it says that the curve C has parametric equations. X is equals to 3 plus 2 sine t, y is equals to 6 divided by 7 plus cos 2t, where t is greater than or equals to minus pi over 2, less than or equals to pi over 2. So the requirement of part A is to show that C has Cartesian equation y is equals to 12 divided by 7 minus x times 1 plus x, where x is greater than or equals to p, less than or equals to q, where p and q are constants to be found. So in part A, we have basically two requirements. First requirement is to find the equation in the form y is equals to fx, where we need to prove a specific form of fx, where fx is equals to 12 upon 7 minus x times 1 plus x. And the second thing is that we need to tell the domain for the fx function, meaning we need to find the range of the values of x. So here I'm going to solve part A. X is equals to 3 plus 2 sine t. This is x as a function of t, and y is equals to 6 divided by 7 plus cos 2t. This is y as a function of t. So as we know the fact that cos 2t can be also expressed as 1 minus 2 sine square t. So in place of cos 2t, I'm going to write 1 minus 2 sine square t. So y is equals to 6 divided by 7 plus 1 minus 2 sine square t. So therefore we have y is equals to 6 divided by 8 minus 2 sine square t. All right. So far we have achieved this thing. So since we know that x is equals to 3 plus 2 sine t, so if we make sine t the subject, this will be equals to x minus 3 completely divided by 2. So in place of sine t, we are going to write x minus 3 completely over 2. So y will be equals to 6 divided by 8 minus 2 times sine square t, and sine square t is basically sine t whole squared. So we can write x minus 3 completely over 2 whole squared. So now in the next step, y is equals to 6 divided by 8 minus 2 times x minus 3 whole squared divided by 4. So now if I simplify this further, I can say that y is equals to 6 divided by 8 minus x minus 3 whole squared over 2. And now you can take the LCM of the denominator of this fraction. You can express the denominator of this fraction as a single fraction, and then you can do the simplification step. Or otherwise, what you can do over here is that multiply the numerator and the denominator of this fraction by 2. Okay, so meaning this whole fraction, I'm going to multiply it with 2 over 2. So this is supposed to be y is equals to 6 times 2 is 12. So 12 in the numerator, and then it is divided by 16 minus x minus 3 whole squared. So now this is basically the form of the difference of squares. So y is equals to 12 divided by 4 square minus x minus 3 whole squared. So now as we can see that the denominator of this fraction has a form of the difference of squares, meaning it is in the form of a square minus b square, which can be factorized into a plus b times a minus b, where a is basically 4 and b is x minus 3. All right, so I am going to continue the working on the top. So therefore, we can say that y is equals to 12 divided by, first of all, I'm going to write a plus b. So 4 plus x minus 3, and then it is multiplied by a minus b. So 4 minus x plus 3. So far, we have achieved this thing. So therefore, we can say that y is equals to 12 divided by 1 plus x times 7 minus x. Hence, we have shown that y is equals to, therefore, y is equals to 12 divided by 7 minus x times 1 plus x. This was required to be shown. All right. But in part A, we also need to tell the domain of the function, meaning we need to tell the range of the function of x as a function of t. We need to tell the range of the possible values of x, and this will basically become the domain of the function y is equals to fx. And for that purpose, I'm going to erase the earlier working so I can make some space. So as we know that x is equals to 3 plus 2 times sine t. So if we compare it with the original graph of sine t, we can see that multiple transformations have been applied. A stretch in the y direction with factor 2 and translation by the column vector 0, 3. But here we have a different domain, which is that t is greater than or equals to minus pi over 2, less than or equals to pi over 2. So our purpose is to find the range of the possible values of x according to the domain of t, which is given to us in the question. And this range of particular values of x will become the domain of the function y is equals to fx. So as we know the fact that sine t is greater than or equals to minus 1, less than or equals to 1. And if we find the range of 2 sine t, this will be greater than or equals to minus 2, less than or equals to 2. Since a stretch in the y direction with factor 2 is applied. So now if we translate it by the column vector 0, 3, so 3 plus 2 sine t is greater than or equals to minus 2 plus 3 less than or equals to 2 plus 3. So 3 plus 2 sine t is greater than or equals to 1, less than or equals to 5. This is the range of x is equals to 3 plus 2 sine t. So if I make a graph of x against t as quickly as possible, so the least value of the graph would be at 1 and the maximum value would be at 5 and the vertical intercept would be at 3. So when t is basically equals to minus pi over 2, you will get the least value of the function. And when t is equals to pi over 2, you will get the greatest value of the function. And the graph would look something like this. So therefore, we can say that when t is equals to minus pi over 2, x is equals to 1. And when t is equals to pi over 2, x is equals to 5. Therefore, x is greater than or equals to 1, less than or equals to 5. Therefore, p is equals to 1 and q is equals to 5. This is supposed to be our answer to part A. So now let's move on to part B, and I'm going to erase the working of part A so that we have a fresh page to continue the working. All right. So in part B, it is said that hence find a Cartesian equation for C in the form y is equals to a over x plus b plus c over x plus d, where x is greater than or equals to p, less than or equals to q. We have already found the value of p and q in part A, okay, where a, b, c, and d are constants to be found. So this means that we need to express the answer of part A, the equation of the curve, into partial fractions. Okay, so we are going to express 12 upon 7 minus x times 1 plus x into partial fractions. And since we know that this is a proper fraction and the denominator has distinct linear factors, so this is equivalent to a divided by 7 minus x plus b divided by 1 plus x. So therefore, we can say that 12 is equivalent to a multiplied by 1 plus x plus b multiplied by 7 minus x. And as you already know that this particular form is achieved by multiplying the denominator of the fraction on the left hand side of the identity completely by the left hand side and the right hand side. This denominator 7 minus x times 1 plus x is completely multiplied on both sides so that we can get this form. So now first of all, I'm going to substitute x is equals to -1 in order to eliminate a and find the value of b. So this will be that 12 is equals to a multiplied by 0 plus b multiplied by 7 minus -1. Okay, so 12 is equals to 8b. Therefore, b is equals to 12 over 8. b is equals to 3 over 2. And then I'm going to substitute x is equals to 7 in order to eliminate b and find the value of a. So 12 is equals to a multiplied by 1 plus 7 plus b multiplied by 0. So therefore 12 is equals to 8a. Therefore a is also equals to 3 over 2. So now we can say that 12 upon 7 minus x times 1 plus x, this is equivalent to 3 over 2 times 7 minus x plus 3 over 2 times 1 plus x. But as we can see that in the requirement, the denominators are having a positive coefficient of x, and the term in x is first written, and then we have the constant term like b and d. Okay, so we need to express our answer exactly in this form. So this means that there is no issue in 3 over 2 times 1 plus x, as in place of 1 plus x, I can simply write x plus 1. This means that we need to do something with this fraction 3 over 2 times 7 minus x. And in order to make it x minus 7, we have to take a minus sign common in the denominator, meaning taking -1 as common in the denominator. All right. So first of all, I'm going to write this fraction 3 over 2 times x plus 1, which is exactly the same as 3 over 2 times 1 plus x. And then plus 3 over 2 times, I'm going to take -1 as common so that I'm left with x minus 7 inside. Okay. So therefore, now we can say that 3 over 2 times x plus 1 minus 3 over 2 times x minus 7. We have expressed the Cartesian equation for C in this particular form. So this is supposed to be our final answer. So therefore, we are going to say that y is equals to 3 over 2 times x plus 1 minus 3 over 2 times x minus 7. So this was the answer of part B. So this was the question number 3 of International A-Level Edexcel P4 January 2022 paper.